These are the frequently asked questions for pre-calculus for section 7.3, day 1. Number 3 says we are to use Gaussian elimination to solve the system of equations. So Gaussian elimination has to do with the fact that what we want to do is get this into a triangular form. So I'm just rewriting the equations here. So we can start there. All right, so Gaussian elimination. Well, what we've been doing in class, I'm going to stick with here and say we're going to use the first one as our eliminator. And we want to rewrite the other two. And like I said, I'll just kind of color code everything here. Now you might have noticed that the middle term does not have a y term, and for that reason, we'd be really tempted to get rid of the y's in the other one first, and you certainly could. Gaussian elimination does allow for us to switch those rows around if we want to, but I'm going to go ahead and do this problem exactly as it is, because I'm wondering if that wasn't where people got stuck, was by the fact that they were trying to do the normal Gaussian elimination like we did in class. So I take a look at my eliminator up here in the green, and I realize that if I want to go after the x's first, which is what we did in class to get rid of the x, the y, and then the z, we would go ahead and multiply everything in the green box here by -2. And add those together. So what we'll get is what we have left here of our 2x minus 3z. Well, we have a -2x plus 2x. That's going to be gone, but now we'll have a 2y, because that's not going anywhere, minus 5z equals -1. Now I go back to my eliminator, and I realize I'm not going to have to multiply that by anything in order to get the x's to drop out of the blue equation. I can just rewrite it and add those together. And that will give me -2y plus 3z equals -1. And, even better yet, I notice that the y's will cancel out if I merely add that black equation to the blue equation. -2y plus 2y, gone. So I will get -2z equals -2. So z will equal 1. And then I can take that and put it back into either the blue or the first black equation. I think I'll put it right back up in here. So 2y minus 5 times 1 equals -1. 2y minus 5 equals -1. 2y equals 4. So y equals 2. Now we have z and we have y, and we will go back up to our eliminator, way up there in the green box, and see what we get for x. So we will have x minus, we just found 2 for y, plus 1 equals 0, and we'll solve that for x. X minus 1 equals 0, you add 1 to both sides, and you get x equals 1. Last but not least, we put this into an ordered triple to show that we understand how all of that worked. So there is our solving the system by Gaussian elimination. We just kept eliminating the variables in order, x, y, and z, in order to get the solution that we needed. Number 18 says find a row echelon form for the matrix. And number 18, I think I'm going to go ahead and do by hand. You wouldn't have to. We talked about this in class. This is a little bit bigger matrix. So we certainly could use a calculator for the 3x3. But I noticed that I already have a 1 in this position, which is great. So now what I need is to get zeros in these two positions and start working on getting my 1s across the diagonal. So first thing I would do is multiply that first row by 3 and then add it to row 2. Now the first row is not going to change, but I'm going to take 3 times 1 and add it to -3. That'll give me 0. And 3 times 2 is 6, and 6 minus 6 is 0. 3 times negative 3 is negative 9, plus 10 is 1. And isn't that interesting what just happened there? Now, I would go ahead and take row 1 times 2 so that I can add that to the third row and get a 0. So 2 row 1 plus row 3. Well, 1 times 2 is 2, and 2 plus negative 2 is 0. And then I have 2 times 2 is 4, and 4 plus negative 4 is 0. 2 times negative 3 is negative 6, plus 7 is 1. So now we look at that and say, well, that's not row echelon form. It doesn't have 1s all the way across the middle diagonal. No, we were able to go a little farther than that, and it just happened with the math that we ended up with a 0, 0, and 1 in both of those last two positions. Saying I just took a minute and punched it in on my handheld calculator that I use on the television, and we get the matrix that we have right here. But if I use the calculator that I have on the smart board, we get a different matrix. And we had talked about that in class about how that row echelon form can have many different looks to it. In fact, infinitely many, depending on the math that you're going to do to it. So this is one of the many answers that would be correct for that one. Number 19, find a row echelon form for the matrix. Getting bigger here. So definitely with number 19, we would want to go ahead and use the calculator. And this was probably one of those where if you just hung in there for today's lesson, you know, everything would be just fine. So we need to get this in, and we will put in second matrix number 1. Let me get that under edit. There we go. And this one is a 3 by 4. And we need to put all the numbers in, which takes a while on the smart board so that I'm sure all the numbers are going in right. So I'm going to pause this and type those in there. And now I want row echelon form. So second matrix. And we can go to math and we can scroll all the way down to A, or you can hit alpha A. Oh, I need to get out of the screen. It didn't clear for me. There we go. So now, second matrix, math, alpha A, and then we pull up its name, second matrix, number 1. And there is the row echelon form. Now, you're going to notice everything's pretty nasty there, so we might try using math, number 1, and have it pop them back into fractions for us so that we don't have to write down all of those nasty decimals. So for number 19, the REF is 14240 negative 1/7 5/7 001 and negative 46/5. Now again, there are lots of different row echelon forms. If you did this one by hand, you might have gotten something very different, which, you know what, maybe I'll take the time to do that. You didn't have a lot of FAQs for me today, so maybe I'll go ahead and do one of these by hand as well. So for number 19, 1, 2, 3, negative 4, negative 2, 6, negative 6, and 2, and then we have 3, 12, 6, and 12. So we go after this by saying, all right, I've got my 1 up here, that's what I want, but I need to get rid of that negative 2. So to do that, I should take row 1 times 2 and then add it to row 2. Row 1 is going to stay exactly as it was, but now row 2 I will replace with whatever I get when I take 2 times row 1 and add it to row 2. 2 times 1 is 2, plus negative 2 is 0. 2 times 2 is 4, 4 plus 6 is 10. 2 times 3 is 6, 6 plus negative 6 is 0. 2 times negative 4 is negative 8. Negative 8 plus 2 is negative 6. So far, so good. And then I realize, well, if I take row 1 times negative 3, I can eliminate that first term for the third row. So I'm also going to take negative 3 times row 1 and add that to row 3. 1 times negative 3 is negative 3, plus 3 is 0. 2 times negative 3 is negative 6, plus 12 is 6. Negative 3 times 3 is negative 9, plus 6 is negative 3. Negative 3 times negative 4 is 12, plus 12 is 24. Now, I notice that my 10 is in a position where I would really like a 1. First row, everything's fine. But what I'm going to do is I'm going to take 1/10 times row 2 so that I can get a 1 in the position I want. So 0 times 1/10 is 0, 10 times 1/10 is 1, 0 times 1/10 is 0, and 1/10 times negative 6 will be negative 6/10, which is negative 3/5. Then I look at the last row, and I realize that I really want a 0 there in that 6th position. That's what I want to make happen. So to do that, I'm going to have to use row 2, and I'm going to have to multiply it by negative 6. So negative 6 row 2 plus row 3. So if I take negative 6 times 0 and add that to 0, I'm going to get 0. If I take negative 6 times 1, I'll get negative 6 plus 6 is 0. If I take negative 6 times 0, I get 0 plus negative 3 is negative 3. If I take negative 6 times a negative 3/5, that's going to give me 18/5. So I will need 18/5 plus 24 in fifths. So 125ths. Because my 24, I need a common denominator to make that work. So 18/5 plus 125ths, which will be 138/5. And then the last thing that I would need to do, because I want a 1 in this position, is to multiply everything by a negative 1/3 in that row. So my last step, negative 1/3 of row 3. 0, 0, 1, and then we'd have negative 138/15. And then we'd check to see whether or not 138/15 is going to be reducible and something a little bit nicer that we can work with. And that is 46/5. So there's my reduced echelon form by hand, and there is our reduced echelon form by calculator. And you're going to notice similarities, but it is not exactly the same. So it's exactly what we talked about in class, where you use different operations to acquire that reduced echelon form, and it may look a little bit differently. I'm going to go ahead and do number 33 by hand. A couple of students had let me know that I did this one with a calculator, and your instructions for your assignment said that you were to go ahead and solve this one by hand. So let's go ahead and make that augmented matrix. And then we will use some row operations to get things as we need them to be. So the first thing that I see is I've got a nice 1 in the first row up there. That is perfectly fine. I don't want to do anything with that, so I'm going to leave the first row alone. But I need to start getting some zeros in those first positions of the other 2 rows. So if I multiply row 1 by negative 2 and add it to row 2, that will accomplish that. So negative 2, row 1 plus row 2. 1 times negative 2 plus 2 is 0. Negative 2 times negative 2 is 4, and 4 plus 1 is 5. Negative 2 times 1 is negative 2, plus negative 3 is negative 5. Negative 2 times 8 is negative 16, plus negative 9 is negative 25. And while I'm at it, I might as well go after the third row by multiplying the first one by 3 and adding it to the third row. So that'll be 3 row 1 plus row 3. 1 times 3 is 3, 3 plus negative 3 is 0. 3 times negative 2 is negative 6, plus 1 is negative 5. 3 times 1 is 3, plus 3 is 6. 3 times 8 is 24, 24 plus 5 is 29. Next up, I notice that I already have opposites in the second and third row, so if I just take row 2 and add it to row 3, that will help me get another 0. So I'm going to leave the first row alone. And, oops, this should be a 3 here. There we go. I will leave the second row alone. But to get the third row, I'm going to go ahead and add this row to this row. So 0, 0, 1, 4. Now, that's really helpful. Already we know that z is 4. But I look at that middle row and I realize I need to have a 1 in this position. And to do that, I'm going to have to multiply by a scalar. So what I'm going to have to do to finish this up is take 1/5 times row 2. So the first row, leaving that alone. The second row, I'm going to multiply by 1/5. So 0 times 1/5 is 0, 1/5 times 5 is 1, 1/5 times negative 5 is negative 1, and 1/5 of negative 25 is negative 5. And then we have 0, 0, 1, and 4. So right here is our x, here is our y, and here is our z. So z is 4, and now we'll work backwards. This equation has y minus z equals negative 5. So y minus 4 equals negative 5. We add 4 to both sides, and y equals negative 1. Go all the way back up to the first row. And let's put our z and our y back in there. X minus 2 times negative 1 plus 4 equals 8. X plus 6 equals 8. So x equals 2. And we have the ordered triple, 2, negative 1, 4. And I think I'll just leave the calculator one in here, but this one you were to do by hand. Number 33, solve the system of equations by finding a row echelon form for the augmented matrix. So we're going to let the calculator totally take care of 33 for us. We're going to put that into that augmented matrix. And we'll get that into the calculator so that we can go ahead and punch this in and get the calculator to give us those solutions. Now this one said a row echelon form, not reduced row echelon form. So we'll get this in that REF form, and then we'll go ahead and do some back substitution with this. So I'm going to hit pause and get this entered in, and then start the video again. In here and ready to go, let me show you. I have it in there. So there is our matrix. And what we want is that REF. So second matrix, math. And again, you can either scroll down to REF or hit alpha A. So there's our REF. Second matrix, pick matrix A because that's where I stored it. There's my REF. And now I could certainly again hit math, number 1, and enter, and get that in fractions instead. So we have x minus 1/3 y minus z equals negative 5/3. And then we have y minus 6/5 z equals negative 29/5. And then we have z equals 4. So we can either do some back substitution, or at this point I already taught you how to do the reduced row echelon form. It's up to you, but I'm going to go ahead and do this one by hand. If I know that z is 4, I can go ahead and plug that in by back substitution. Y minus 6/5 times 4 is supposed to equal a negative 29/5. Well, good news, we're going to have a common denominator here. Y minus 24/5 equals negative 29/5. We would add 24/5 to both sides. And we'll get negative 1. Now that we have y and z, we can go back up to the first equation and figure out what x is. So x minus 1/3 times negative 1 minus 4 equals negative 5/3. X plus 1/3 minus 4 equals negative 5/3. So x plus 1/3 minus, and if we need this in thirds, it's going to be 12/3 equals negative 5/3. So x minus 11/3 equals negative 5/3. And then we'd add 11/3 to both sides. And x will equal 6/3, which is 2. So lots of dealing with fractions because of the reduced echelon form that we received here. But our ordered pair in the end comes out to be some really nice integers. 2, negative 1, 4. And that is the end of it. Mention on this last one, depending on your calculator type, again, your row echelon form when we reduce this might be quite a bit different than what I have on the TI-84 plus C Silver Edition. And again, as long as it'll give us the same solutions, that's what we care about. And both reduced echelon forms on both calculators will give you 2, negative 1, 4.